All right, it's 8:30, so let's get started. Welcome to day 2 of WAFR 2022. Hopefully all of you enjoyed day 1. We had several interesting technical talks. I thought a very thought-provoking open problem session, a great keynote, and hopefully all of you enjoyed the banquet in the Brendan Eyre Center for Computer Science and Engineering. I'm supposed to say the entire name. Day 2 is going to be just as much fun, if not more. We have, again, 3 technical sessions. We have a keynote that I'm personally looking forward to. And then at the end of the day, we have a special lecture remembering John Paul Lemon, followed by banquet in DC, which is what I think all of you are looking forward to. Just a note, if you were not here yesterday, all our technical sessions have either 3 or 4 speakers. Each presentation is 14 minutes, including the dirty laundry slide, 1 minute for changeover. And then at the end of the session, we have a common Q&A for all the talks for 15 minutes each. Right? So we'll start off with our first technical session for the day. Let me hand it over to our session co-chair, Professor Dylan Schell from Texas A&M.
Thank you, Pratap. This is session 4, which is the first session from today, for today, of course. And the topic or the theme which kind of unites the 4 papers that we're going to hear from are distributed systems interacting with multiple agents, and there's some instances of teamwork, which is going to show up in a couple of the talks. So I'm quite excited about that. So let me not take any time from our speakers. So the first talk is going to be given by Jieheng Hu. The title is Large-Scale Heterogeneous Multi-Robot Coverage via Domain Decomposition and Generative Allocation. And this is joint work with Howard Coffin, Julian Whitman, Matthew Travis, and Howie Chositz. Thank you.
Okay, thank you so much for the introduction. So yeah, I'm happy to start today's talk. So the problem we're interested in this work is the large-scale deployment of heterogeneous robots for multi-robot search and coverage in time-critical scenario. That's a long sentence to parse, but what I'm trying to say here is we want to simultaneously deploy a large number of robots with different capabilities, and we want to deploy them to search or cover a target region, and we want to do it in a short amount of time. Traditionally, this can be done through either a centralized approach or distributed approach. In centralized approach, you would have a central server where all the agents would communicate with, and the central server would do the planning for all the agents and tell the agents where to go. Obviously, you'd suffer from computational inefficiency in this case, and typically the computation cost would scale exponentially with the number of robots, making it unsuitable for large-scale deployment. Alternatively, there's this distributed approach where each robot is making decisions based on local information, local observation, local interaction with the other robots. But obviously, at the very best, your robot can only make locally optimal decisions, so you're going to have some performance drop. So our idea for this project is really, can we take the best of both worlds? Can we enjoy the computational efficiency of the distributed approach, but somehow consider a global information in the meantime so that we can put the capability of the robots, especially heterogeneous robots, to better use? So our idea from a really high level is a divide and conquer approach, where let's say we started off with the target region we want to cover, which can be represented as a satellite map, as you're seeing on the left of the slides. You can first represent it as a terrain map on the right of the image, where each terrain label would signify a class of terrain that pixel belongs to. Our first step would be to divide up the search domain to smaller and more manageable search regions based on the terrain labels. Next, we want to allocate robots to each of the subterrain or subregion based on both the terrain label and the robot capabilities. And then we want to plan in each of the subregion in order to cover up each of the subregion efficiently. So this pipeline, I think, sounds decent, but we really have to answer the question of how do we divide up the search domain and how do we allocate the robots into each of the subdomain to utilize their capabilities. And that's going to be the main focus of my talk. First, let's look at the domain decomposition. So our idea